Continuing our journey with complex numbers in polar form, we're going to now learn how to multiply and divide. So we've previously looked at this in Cartesian form, and of course the results are the same, but the form varies. So if basically you use some identities involving sine and cos, or trig identities that involved angle, sum, and angle difference, you could show the following. So trig angle sum and angle distance gives the following. So if we have two complex numbers z1 and z2 in r1 cis theta 1, r2 cis theta 2 form, the product z1 times z2, we multiply the two moduli, i.e. like the two magnitudes, I suppose you could say, but the modulus of number 1 and modulus of complex number 2 is multiplied together, and we sum the angles, so the two arguments are added. If so the order doesn't matter with that one, but the order does matter with division. If it's z1 divided by z2, we have r1 over r2, and we have cos I sine theta 1 take theta 2. So we divide the moduli in the correct order, and we subtract the arguments in the correct order. So please note that. So quickly in our example here, we're given two complex numbers, and we have z1 2 cos I sine theta and z2 4 cos I sine 4 cos I sine 20. So we have to multiply these because it says find the product z1 z2. We also have to represent it on an arcane diagram. It's interesting to see the results. So the rule that we just introduced is applied, as you can see, and we get 8 cos I sine 50 degrees. On an arcane diagram, we've got the two original vectors z1 and z2, and you can see that between them two things. Straight from the rule, we can see that we have a multiplied modulus now. So the modulus is the multiple of r1 and r2, and the argument is the sum of the two angles. It's now at 50 degrees. So it's quite straightforward representing that on an arcane diagram. You could also draw this diagram using the radial format that we saw in a previous video with concentric circles and radii coming out at constant angles. Finally, we look at division. So given z1, this one's in radians. Okay, the other one was in degrees, this one's in radians. So we can look at complex numbers in radians, but also degrees when we're in polar form. So just like with two-dimensional vectors that you've learned so far, you need to be able to deal with radians and degrees. Here we have to find the product z1, z2. It's pretty much the same. We just need to remember how to add fractions of pi together, and then simplify. That comes down to 4 pi on 3. Now, because the principal argument stipulates between negative pi exclusive and pi inclusive, we need to rewrite that as such, and sometimes you may need to draw a diagram to visualize this. If we had to deal with this question here, it says find the quotient z1 over z2 expressed in Cartesian form. This solution here is only one possible way. It says Cartesian form, so one way is to go Cartesian, polar, Cartesian. But it is possible just to stay in Cartesian. That's a C, believe it or not. So you don't have to convert this one to polar form, but it is a good way to demonstrate the division of complex numbers in polar form. So what happens here, using our known formulas and rules, we convert Z1 and Z2 into polar form, and we've seen that previously. Once they're in polar form, we have this line here, and we apply basically the rule we've just established, and we get a half cos I sine 2 pi on 3, and then convert back to Cartesian form. So just remember, the order is important. The designated first complex number Z1 sits on top of that quotient there. Thus, it's R1 over R2 and theta 1 minus theta 2 in that correct order. I wonder if you could do this one without converting to polar. If you're really sharp, maybe you could add that to your notes. How could you deliver this in a way without converting to polar form? If you can put that in your notes, show me, and I'll have a look at that.